find exactly the average value of the function on the given interval. We have a piecewise function, f of x equals x squared when x is greater than or equal to -2 but less than or equal to 1, and it equals e to the x when x is greater than 1 but less than or equal to 5. We need to find the average value of that function on the closed interval between -2 and 5. So for an average value, what you're doing, you're finding the total area enclosed by this thing, and you're effectively turning the shape into a rectangle. So whatever the graph looks like, you're just imagining that every f of x, every y value was the same, making every y value the same, but not changing the area. So the formula is that the average value equals, so it's 1 over b minus a. So that is just, remember, b minus a is the width of the interval. So our b is going to be 5 and the a is going to be -2 times the integral between b and a, or a and b, sorry, of f of x dx. So if we think in terms of rectangles, this bit here is the area, and this bit here, well, 1 over b minus a, is the width. So this is 1 over the width. So basically you're doing area times 1 over the width, which is the same as area over width, which, if you just think about a rectangle, gives the height. So say you've got some function with different values of y all over the place as x varies. You find out the area enclosed by that, and then you divide it by the width of the interval, and it will give you the same area if every y value is the same. So we're using an average value. When you find averages, what you do, you make every number the same, make every value the same. That is what we are doing. So we have a bit of a problem because we need to do two separate intervals and two separate integrals. So we need to, for x between -2 and 1, we need to use x squared. And for x between 1 and 5, we need to use e to the x. The 1 over b minus a bit is fine. So we have average value, well, it's going to be 1 over b minus a. I just said b was 5 and a was -2, so 5 minus -2 of, well, you've got the integral between -2 and 1 of f of x. Well, in that particular case, f of x is x squared dx, plus the integral between 1 and 5 of e to the x dx. So we're going to have to do these separately, or it's not going to work. Right, 5 minus -2 is 7, so that's 1 over 7 times x squared integrates to x cubed over 3. We're going to evaluate that between 1 and -2, plus e to the x just integrates to itself, and we're going to evaluate that at 5 and 1. So that is going to be 1 over 7 times 1 cubed over 3 is 1 over 3, minus -2 cubed over 3, or 2 cubed is 8, -2 cubed is -8 over 3, plus, well, then you've got e to the 5 minus e to the 1, so e to the 5 minus e to the 1 is e. Right, so thinking about these fractions, well, you've got the 1 over 7 we'll leave for a minute. 1/3 minus 8 over 3 is the same as 1/3 plus 8/3, which is 9/3, which is 3. 3 plus e to the 5 minus e. And I'm tempted to leave the 1 over 7 out. Because we've been asked for the exact value, there's no need to put this into a calculator, and actually expanding this bracket is not going to make anything look any better. So I'm just going to leave that as so. So we've now found the average value. Remember, it's equivalent to turning this whole area into a rectangle, turning the curve into one rectangle with one consistent height without changing the area under the curve.